Okay.
So I am creating new file vih2.xyz. Then I'm typing the letter I to start inserting I. And then I typing it's my h2 for the name. Then I type just two numbers, two atoms in this, then empty line, and then first atom is hydrogen, x equals 1, y equals x equals 0, y equals 0, z equals 0. Second hydrogen, x equals 0, y equals 0, z equals, let's say, 1. Now I typing escape, shift colon, WQ to save. Now I do have the file which shows atomic coordinates, 3 Cartesian coordinates for first atom and 3 for another atom. This notation is good, but for computer, it looks a little too short. So typically for computer standard format, it needs longer, several digits. So I'm going to convert it first to PDB and then return back to XYZ. And if you need, after I'm done, I will copy paste all commands to you. But let me quickly go through so that you see
Okay.
it is real.
So wait, just to understand the aim of what so the way I understood what I'm supposed to do is, if I have a text.com file, but I want to analyze it and I don't want to use Gauss view.
Right.
Okay, so I was thinking, so what does .xyz mean? Because I just thought, oh, so I created so I picked up the molecule that I built .com and I was trying to analyze it. So, but I'm seeing XYZ and I don't really understand. I thought it's supposed to.
So each atom in the molecule has 3 coordinates, x, y, and z.
Okay.
And if you have molecule with 2 atoms, there is a XYZ for first atom and XYZ for second atom.
Okay.
And if there are more, if there are like 10 or 12 or 100 atoms, for each atom you need to have 3 numbers. And it is the simplest way to create a molecular model.
So are you saying at the end of the day? Okay, don't worry, continue. I still don't. I don't know if I'm not asking my question correctly, but don't worry, go on. I mean,
yeah, no, question simple. Now I'm going to convert this file into PDB and then back into XYZ, so the format will be better. Minus I XYZ, input XYZ, minus output PDB. Done. Now I'm looking onto this file just in case. So it's not user friendly. It has same information, but it's kind of ugly. So here X, Y, and Z are here and there of this molecule. And now I'm going to convert it back into XYZ. So take PDB as input minus I minus output enter, one molecule converted.
Why does the
yes, please ask.
The extreme dot xyz. Why does it have two before it? The PDB doesn't have two.
Oh, I just created file with new name. Same as when you create something with Microsoft Word, you name your files as you want.
Okay.
So now I'm looking inside this file, and it has the same information as before. So before we had two atoms, first hydrogen, second hydrogen, and three coordinates, 0, 0, 0, 0, 0, 1. Now we have the same. First line shows number of atoms, then second doesn't matter, it's just comment, and then first atom hydrogen, and the coordinates are 0, 0, and 0, just more larger number of digits. Second atom hydrogen, and we have a 0, 0, and 0. This format of larger spaces between numbers and several sig figs is what makes computer happy. Now, next step. I need to create .com file. So first, I do have the template of the artifact calculation in this file, and it has this standardized things with which ends with 0, 1.
Okay, so why does it pull up CIO4H4? Why?
Which one?
Why does it this percentage CHK equals TIO4H4.CHK? Why is it pulling up TIO4H4?
Because I was using it as a template earlier. We can modify it and put something more reasonable. Put H2, which will be better.
So is it that the H2 is saved? I just want to understand, like, is it like the H2 is saved somewhere, or the TIO4H4 was saved somewhere?
Not yet. Not yet. There
So
are.
where is this calling it up? Where is it calling it from?
I understand your confusion, and you will resolve it in a minute. So you will see it in maybe like 100 seconds. But the .com file consists of two segments. First segment is like request for some service, and second, list of atomic coordinates. This template that I'm showing, it's only request for some service, for some calculations. And the file that we just have created, this one, is list of atomic coordinates. Now we need to combine these two files into one file. So to combine two files into one, I type cat, which is concatenate rather than animal with whiskers. So concatenate this service file. Then second will be this atomic coordinates. Then I tell bigger, and then tell maybe test h2.com. So now I can check if I have created this file correctly. So if I look to more test h2, you see first part is what we had in the first part, in the first file, right? You recognize it. And the second half is a list of atomic coordinates. So we combined two files into one. Now, before we proceed, I want to delete these two lines because they're not non-standard for Gaussian. So I'm going to open this new file and delete two lines in between. So I'm typing VI for the editor, VI. And then going down to the lines that I want to delete, and then type DD. Two letters D, one after another. Once again, DD. Now it is deleted. type I to insert, go to the end of the line, and hit enter just in case a couple of times. Now to save it, I type escape shift colon WQ and file is saved. Now if I look into this file once again, it has exactly what we need. So initial part is request to run HartrFork with 102DZ for neutral configuration in singlet state for H2 molecule, where hydrogens are displaced in comparison to one another along the axis. So this is the most complicated part, and we will drill and try for you to repeat the same steps. And I will answer any questions. Now let me show what we do next with this file. So I can run Gaussian for this specific file, test H2. And before I run it, I had these files ready. Then I hit enter, wait, and then look for available files once again, ls-14. You see, there appear two additional files, h2.check and test h2.log. You see it?
Yeah.
So now, if I look inside this test2.log, it looks same way as if I would run Gauss view and submit a Gaussian job through it. So if I go through this file, you will see everything we yes, you see we have alpha occupied, alpha virtual. You remember these symbols, right?
Mm-hmm.
And since it is H2 molecule, it has only one orbital with 2 electrons, which is occupied. So therefore, there is only one. And there are several unoccupied orbitals. So basically, we did everything what we typically do by Gauss view, just by typing commands in the command line. Okay. Now, I would be curious to check if you have some questions before we proceed further.
No, I don't want a question.
Okay, then, so here is my plan. I will copy paste all commands that I was typing, or most commands, in the chat line, so that you have them for your reference. And then maybe you will share the screen and try to repeat them. Just one little demonstration before I go there. So if I open Gauss view, I can file open .log. So here is the file that we just created. It was test h2.log, right?
Mm-hmm.
So I click open. And then it looks like only one sphere, but if I click and slightly rotate, so it shows 2 hydrogen atoms. It doesn't show the bond, but actually it is hydrogen molecule that we just created. So we created this molecule without drawing, without using mouse, only in a command line. And the goal of this exercise is to prepare everyone in class to the next steps. When we will be doing high throughput modeling of large number of models, one cannot do everything by mouse. It will be too much. And in command line, one can be more productive. Whew. So I will probably stop